square minus ax plus 3 for rational values of x, and f of x is defined as 2 minus x for irrational values of x. This function is continuous at exactly 2 points, then we need to find the values of a. Look at this. This function is continuous at exactly 2 points, and the function is defined with one definition for rational values of x and with another definition for irrational values of x. See, already we did this type of problems. If a function is continuous and its behavior is same at each and every point and in its surroundings. Okay. For suppose if this function is continuous at a point, then for sure at that point the definition of the function for rational value as well as for irrational value both are equal. Why? Because if you say function is continuous at a point alpha, then in the smallest neighborhood of alpha there exist many rationals and many irrationals. For all those inputs of rationals and irrationals, the behavior of the function is same. That in turn represents that in the surroundings of alpha, the function definition for rationals as well as for irrationals both are equal. And that's why, see, since this f of x is continuous at exactly 2 points, that in turn represents that by this idea, these two definitions are equal. That in the sense x square minus ax plus 3 is equals to 2 minus x for exactly 2 values of x. For exactly 2 values of x. From there, we need to fix the value of a. Okay. Now observe this. These two are equal for exactly 2 values of x. How to find the values of a? This implies when you collect everything this side, x square minus ax plus x. That means x of 1 minus a plus 3 minus 2, that means 1 is equals to 0. This is true for exactly 2 values of x. That means this is equals to 0 has exactly 2 roots. Has exactly 2 roots. So this equation, it's a quadratic equation in terms of x, and this equation has exactly 2 roots. Now the problem is just converted to quadratic problem. A quadratic equation has exactly 2 roots if its discriminant is greater than 0. So that implies its discriminant is greater than 0. And what is the discriminant? I think you all know about the discriminant of a quadratic equation as b square minus 4ac, which is greater than 0 here. B is this x coefficient, a is this x square coefficient, c is constant 1. From there, this implies 1 minus a whole square minus 4 into 1 into 1 greater than 0. So, this implies, have a look, this is 1 minus a whole square minus 4 is greater than 0. We need to fix the values of a. That's our task now. See, 4 can be written as 2 square. So just rewrite this 4 as 2 square. And then use something like alpha square minus beta square or a square minus b square formula. So 1 minus a plus 2 into 1 minus a minus 2 is greater than 0. See, this is 3 minus a. This is 1 minus 2 minus 1 and minus a. When you multiply these two terms with minus sign, so I have 3 minus a as a minus 3, and when you multiply or when you collect minus from these two terms, minus 1 minus a will become 1 plus a, and this is greater than 0. Finally, a minus 3 into 1 plus a greater than 0, that in turn represents that the values of a are on either sides of the roots. So a value is either less than minus 1 or greater than 3. Okay, have a look. So that's the answer. You just observe the problem first. Okay, as I mentioned, this equation is continuous exactly at 2 points, That in turn represents that these two are equal for two values of x. So that means this quadratic equation has exactly two roots, means its discriminant is greater than 0. So discriminant greater than 0, when you apply at the end the values of a are either less than -1 or greater than 3. That's your answer. Okay. Have a screenshot of this.